Hello, everyone. My name is Sean Barrow, and this is Achieve Compliance in ISO 26262 Faster in a GitLab CI pipeline. While the title states that we're going to be talking about ISO 26262, and that will be the focus today, the techniques that we'll be talking about can also be done with any of the different functional safety standards. So, just keep that in mind in case ISO 26262 is not your standard. The two speakers today, besides myself, are going to be Andre Madan from Parasoft. He's the lead solution architect, and Neil Langmead, who's our director of professional services. Andre will be going through a couple slides on a high-level overview of Lattix and Parasoft working together in a CI pipeline and how that relates to functional safety. And Neil is going to be giving a demonstration of all of this working together in a GitLab CI pipeline. So just a little bit about Lattix. We do architectural analysis solution. It allows you to understand, define, and control your software architecture. So you can understand what the current architecture is with the DSM. And then once you have a clear picture of that, you can define or refactor it, your architecture to go back to what you may have originally wanted, or to a microservices architecture or some architecture like that. You can also, once you do that, you can control the software architecture, monitor it over time. This can help with ISO 2626 compliance and other compliance standards, specifically with data and control flow coupling. We have a number of supported languages, and we have a lot of services through our partner Code Clinic, refactoring code and build, compliance and functional safety, and DevOps and automation. So if you're interested in any of that, feel free to get in touch with me or Neil, and we'd be happy to speak with you about helping you in any of these functional safety areas. So with that, I think I'll turn it over to Andre, and he's going to go through some slides on the Lattix. So.
Yeah, thanks, Sean. While you were talking about Lattix, Sean, I realized that I actually used Lattix back in the day when I was at Medtronic. So it's an excellent tool, and I'm happy for Parasoft to partnering with Lattix. So a couple of words about Parasoft. Parasoft, we are a global company with many customers around the world that are using our testing tools and technologies to test business and safety critical applications. So basically think of it, when the software quality is important to anybody, either it's automotive or medical or mil-aero or industrial automation, or maybe it's a banking application, chances are that Parasoft tools or similar tools are being used in all testing phases of SDLC. But look, if you want to learn more about Parasoft, go to our website, parasoft.com. Has a lot of useful information. All right, let's get to agenda. Today we have a packed agenda. We will highlight Parasoft and Lattix partnership, and then what does it bring to the table. But it brings a unique blend of tools and techniques and technologies covering wide spectrum of methodologies necessary to cover ISO 26262 Part 6 requirements. So I just said a lot of things here, but the important thing is what exactly is ISO 26262? It's a functional safety standard. It's a document that is used applicable for electronic systems installed in road vehicles. That document, the important thing is that it has many parts. The part that we will be covering today specifically is Part 6, which is specific to software. And just as a side note, that document has been derived from 61508 standard, which is the base for many standards like 62304 or DO 178B for avionics, or 61508 for actually industrial automation is using that standard as is. So a lot of concepts that we will be discussing today are applicable across all safety critical industries, not just automotive, but as an example, we'll use ISO 26262 today. The bulk part of today's webinar will actually be centered around demonstration of the live demo run by Neil. That's where he will showcase how Parasoft and Lattix tools can be executed in the context of a GitLab CI pipeline. So that's the exciting part. But before we get to that exciting part, I just want to go through a couple of slides to set the context for the demonstration today. All right, let's talk about what exactly the tools do. Like before we start putting them in the context of the CI pipeline, what are we trying to achieve there? The tool that we will be talking about from Parasoft side is called C++ Test. It's a unified testing tool which encompasses many testing techniques. For example, static analysis that can detect, find real bugs in code, and then help enforce coding standards such as MISRA, AUTOSAR, CERT, and others that are popular right now to achieve, to help people drive higher software quality. Another aspect of a tool is unit testing, where we can, the tool helps you quickly create and execute unit tests on either host or your embedded target. The tool helps you to isolate components using stubborn and mucking frameworks, trace it to requirements and whatnot. The important thing is once you executed the tests, you want to know how well you covered your software, and we report various coverage metrics. The important thing here is that we report all necessary metrics that are necessary for that compliance, for all of those compliance documents. Specifically today, we will be covering ISO 26262. Why is it exciting to have both Parasoft and Lattix join forces and put the solution together in the context of CI/CD integration? Once we go over the presentation, you'll realize that ISO 26262 compliance document has a lot of parts. Like, okay, you have to do static analysis, you have to show code coverage, you have to do architectural explanations. Well, Parasoft and Lattix together do give you all of those techniques that are necessary, and on the top of it, putting it nicely in the context of GitLab CI pipeline, and then at the end, producing necessary documentation. So that's a very unique approach, and I think it's very powerful, which we will be demonstrating later today. Okay. All right, so boring stuff, real quick. If you look at the compliance functional safety document, you'll find some tables. Those tables are, nobody wants to read them, but they are important if you want to pass your audits. Some of the tables, they refer to architectural design, and then they want you to not only describe your architecture in some way and fashion, but they also want you to kind of verify that the architecture meets certain criteria. So that's where Lattix comes in. With Lattix, you are able not only to describe and analyze the architecture, but also put it in the context of the CI/CD pipeline, so that some of the properties, important properties of the architecture, are verified on every single build. Now, more tables, more boring stuff. But one of the tables talk about once you settle on your architecture, you decompose those requirements into the bigger blocks. Now you start coding. Once you start coding, there are some principles that those documents want you to adhere to. Like, for example, you want to make sure that you don't use uninitialized variables, which is line 1C here. So you want to restrict people to have some conversion of types, right? So now all of those techniques can also be automated. All of those problems can also be automatically detected with the use of static analysis, and that's where Parasoft comes in. And in the context of the demo, we'll demonstrate you how those techniques can be automatically executed in the context of GitLab pipeline. All right, more tables. Table 7, 9, and 8, they talk about once you wrote a software, now you want to unit test it. And Parasoft has a very robust unit testing framework that already said can be executed on target or host, where we can collect code coverage, trace it to requirements, and add our secret sauce there. In some cases, static analysis is also pertinent to verifying some of those tables that have to do with unit verification. So the combination of our unit testing and static analysis framework brings you the ability to completely cover those tables where appropriate. Some of those, like inspection 1C, will have to be covered with code review. Okay. All right. With that, I think I just mastered it, like 10 slides in what, 2 minutes. So, Neil, I will now pass it over to you to show us the product, both products in action.
Thank you very much, Andre. Hopefully you can see my screen. So some of those tables that Andre was just talking about there, I've got them here to show you. Extremely tedious to show manual compliance to many of these clauses, as Andre was saying there. How wonderful would it be if we had a means of taking these clauses, mapping them to tools such as Parasoft, C++ Test, and Lattix, and then producing automatically a documentation that shows compliance to these clauses? Wouldn't that be great? So that's kind of what we're excited to show you. The tables, as Andre was saying, talk about architectural level and unit level. And so some of the activities that we take during software validation to part 6 and verification activities, some applies to architecture and some of it applies to the unit level. We have blended the parts of the tools that cover unit integration and architectural level compliance activities and produced one seamless report at the end that shows that compliance. Moreover, we've done that in the context of a GitLab CI pipeline. So many software developers now are using Git or some kind of Git-based methodology. GitLab we have very tightly integrated with the merge request, so that as developers create branches and make changes on branches, at the right time when they're ready to merge their code into the master branch, the software quality data that you need to make a decision about whether the code is good or bad is presented at exactly that point. And in similar systems such as Bitbucket from Atlassian, where it's more commonly called a pull request, the data could also be put there. So let me jump to a very simple project that we have in something called LPDOP, which is the Lattix Parasoft DevOps pipeline. And here we have a project called ISO-AGlib, which is a C and C++ embedded system. It's commonly used in automotive projects and in many other applications. What you see in this pipeline also applies to other standards. We have a version of this pipeline for the FDA, for medical devices, and also for 61508, which, as Andre was saying, was the origin of many functional safety standards, and also for DO178C, for avionics, where you need to take care of things like data coupling and control coupling. So ISO-AGlib has various layers. You can see that someone has taken time to communicate the architecture through a diagram. And these gray modules here are optional. And these green and yellow and blue modules are mandatory core parts of the system. And the Part 6 document would say that you need to do some architectural verifications. So one aspect of that would be checking that your structure is as it is intended to be according to this diagram. So with Lattix, we can import the code or the model, if you're using a UML-based system, and visualize the architecture. We have the means now through a new Parasoft module. We have a module type for Parasoft that pulls directly the dependency data from Parasoft into Lattix and visualizes the dependencies. So the good news is if you're using Parasoft already, it's no matter at all, it's no trouble at all to load the data here. Parasoft, for example, into a new project, add the directory, and create the DSM. And it literally just takes a few moments to analyze what's there. What we're doing here is taking the Parasoft C++ data, which comes from the EDG front end. So many of you know that the EDG parser is one of the world's best parsers for C and C++. Can visualize the whole abstract syntax tree, and that's what we get when we import that data. And you can see straight away the structure of the architecture. The first thing that we do is something called partitioning, which is organizing the system by usage. There's many different architectural algorithms that we can use to partition a system, but most commonly used is components, because that is a very natural grouping of components that are used heavily. It puts those at the bottom. Things like utilities, OS, print routines, things that are libraries tend to go to the bottom of the architecture. And then at the top, you have your application layer. And so we're going to componentize, partition by a component recursively through the system. And you'll see that that restructures and organizes our system by usage. And now you can see the structure, and you maybe see some structural problems already. What you're seeing now is the dependency structure matrix of Lattix, the DSM. DSMs are great ways to visualize structure and also identify opportunities for improving the architecture. Typically, we call that refactoring. The way we read a DSM is we read across the rows to see what a component is used by. So, for example, part 5, network management, is used by part 10, task controller, 137 times. You can see those usages. You can even click to the line of code, and you can actually identify all of the dependencies from one component to another. We read down the columns to see what a component is using. So we can see part 5, network management, is using the hardware abstraction layer down here. It's using utils 209 times. And so we get a sense of the strength of usage between components. You can also see here, this component is heavily used and it's using lots of things both above it and below it in this hierarchy. We call those kind of components change propagators. They are extremely difficult to test. If you make a change in layers like this, they cause huge impact across the whole system. And indeed, that's one of the main use cases of Lattix, is to do an impact analysis. So if any file was to change, for example, let's look at something in the utilities layer. We see a header file here that's used quite frequently. If we mark that as changed, or if a change is detected in our GitLab CI pipeline, then we can automatically calculate the complete impact of changing that file to something called transitive closure, which is basically the mathematical complete effect of changing a component, the complete effect on the whole system. And changing that file impacts, as you can see, 6 different levels transitively. 16% of our system would be impacted by a change to that header file. Up to now, many customers have just been blindly retesting everything when a change is made, particularly if something is due as merge to master. However, as our software gets larger, it becomes computationally infeasible to rerun every test, particularly in a functional safety environment where you have maybe a million test cases that are driving your coverage. So let's have a look then at what this would look like if we made a change in our CI pipeline. Let's pick this example, util functs. You can see here that util functs is quite low down in the architecture. Maybe we want to make sure that our utils, firstly, is not actually using anything above it. This is what we call an architectural rule, and we can use Lattix to enforce architectural rules. You'll remember from the diagram here, many of these are independent subsystems. We can actually set in Lattix that these should be independent subsystems. So let me do that first. I'm going to say that these parts of our system should be independent subsystems. And now we start to see red violations where there are actually dependencies between these components where there shouldn't be. And maybe I want to preserve this structure as well. So I'm going to create layering rules, and automatically we will enforce this hierarchy. By the way, most dependencies in a traditional software system should be below the diagonal. That means components above are only using things below. Usually it's relationships above the diagonal that are causing concern, such as this one. You can see util is using something quite high up in the COM layer, which is undesirable. Generally, the bigger the distance from the diagonal, the greater the concern. The concern here is that because utils, as its name suggests, supposed to be used as a library, it shouldn't really be using any components above it in the hierarchy. So ideally, we want to refactor that to decouple it, and we can do that. The tool will give us hints to remove dependencies. For example, if I show you here, I want to decouple driver from the top part of COM, there are 2 suggested moves to enable that decoupling. I can click OK here, and you can see the number of relationships has now dropped. I've attempted to break open the dependency from COM to util. I could continue that work until all of the relationships were below the diagonal. And then I have more modularity, I have more independence between subsystems, and that's a good thing. The DSM also reveals to us which parts of the system are independent of each other. So you can see all of these squares where there are no relationships, these components are independent. For DevOps, we can now parallelize the building of such components, and we call this approach smart build. If you have a huge system that's taken a long time to build, why not componentize it, parallelize the building of components which are independent, use this architectural approach to establish which parts are independent of each other, and then you will realize huge build speed improvements. We worked with a medical company in the US and achieved that, reducing their build times from 2.5 hours to 20 minutes through this approach. Not only does it improve the building, but if you decouple and modularize, it also improves your testing. In fact, you can actually do a bottom-up testing approach directly from the architecture through our scripting interface, and you can actually link to Parasoft C++ test and create integration testing environments directly from the DSM. So for example, here, you would want to pull in all of these dependencies in an integration test and use those stubs and mocks that Andre was talking about. So now we've set some rules, and it's time to break them. Rules are there to be broken sometimes. So let's have a go at doing that. I'm in my GitLab CI pipeline which integrates Lattix rules checking with Parasoft. Also, on my desktop, if I show you the code for that utils function that we were talking about in the library, I'm going to show you how to make some changes and then see that this pipeline will run automatically. So let's go to that util funcs here. GitLab has an IDE integration where you can make changes directly in the branch. And I'm on my master branch at the moment, and I'm going to take a function where I know I've done some tests, and I'm going to break that function. So let me show you just a simple function, get C string count down here, and it has a while loop. I'm going to change the logic of this statement. Let me first of all show you though, at the desktop, I have Parasoft C++ test. Here is the same function on master that is showing me 100% coverage. And so you remember from those part 6 documents, we need MCDC coverage, we need decision coverage, we need statement coverage. Here we have 3 unit test cases that pass for this function. Everything's looking really good. Also, we are testing using something called a Lattix taxonomy that's been built with C++ test. Let me just find that a second. On different configurations, you can see that we've enabled some of those checks that Andre was talking about for AUTOSAR compliance, for control flow, data flow analysis. Parasoft has what we call taxonomies that group various checkers to match the functional safety standards, the most common of which is the AUTOSAR C++14. C++17 is also supported. And so we're going to enable all of these checks. Also, if you are doing unit testing to a functional safety standard, you can use one of the pre-configured compliance packs for C++ test. As I say, there's the AUTOSAR C++. You can also use various MISRA formats and flavors, and of course our beloved ISO 26262 up to ASIL D, which, as I say, requires that 100% MCDC coverage. So we're enabling these checks, and lots of other things you can do with static analysis: find duplicate code, optimize your code, find unused data. You can use metrics to measure complexity. That's slightly outside of the scope of this, but there's a lot you can do with C++ test at the desktop and in the merge request. So here we have our function. We're going to break that. I'm going to change this not equal to equal, which I'm hoping such a serious change would break the existing unit tests. And then I'm also going to now add a bad dependency to part 10 of the COM component. You remember from the DSM, COM is high above up here, utils is down below, and we set some rules to say that that cannot be used from the utils layer. I'm also going to introduce some open source components, and we have a scanner with GitLab that will just check for open source compliance. And I'm going to now commit this code for Parasoft Lattix demo. That's my commit message, and I'm going to call this Lattix Parasoft. And this is going to create a new branch and also start a merge request as soon as I commit this this code change. Okay, so I'm going to commit this now. Here's the merge request that is automatically created in this workflow, and submit the merge request, and that will kick off several things. So firstly, this is what the pipeline looks like. So this is a GitLab CI pipeline. Typically, you have a build, test, analysis, consolidation phase. And then after the build and test, we go to architecture to check the rules. And we can do a consolidation phase that will automatically produce this documentation for us for part 6. So you probably noticed as we kicked off the merge request there, if I go to my merge requests, you can see that this has now just been opened, it's been updated, and it is being run as we speak. So here's the pipeline running. You can see that we are in the middle of the testing phase. The build phase is completed. And so there's nothing like watching a pipeline run. Just to explain a little bit about the infrastructure that this is running on. It's a very modern DevOps stack that this uses. First of all, you're seeing the GitLab runner. So C++ test, Lattix, all of those tools are configured to run with GitLab. We use the Kubernetes DevOps platform for orchestration, together with Terraform in the background. We use Docker containers to abstract the licensing and installation of all of these tools. So the way that's actually done is through what we call DevOps infrastructure as code. It's done through a GitLab CI YAML file, and that automates those stages here. We have, as I say, those separate containers, and then we have a DocOps stage that does the consolidation of the data from all of those steps. The images then, so the Docker containers, as I say, are pre-configured, and both Parasoft and Lattix have a unique DevOps license that will enable this infrastructure. So if you're using AWS or Azure or one of those platforms to do hosting and to do your build configurations, all of that would work in your environment too if you're using something other than GitLab. Okay, so let's go back to the merge request and the pipeline. We are running away now with the testing step. And something else to show you about the Parasoft step here. There we go, it's running now on our infrastructure. As a user of this system, I don't need to know how all of these tools work. And this is a big change from the way I used to work, because I used to have to know all the options and configure all the tools. Now this is seamlessly running on an infrastructure pre-configured for me. Anybody can use this infrastructure, and that's one of the benefits of DevOps, is that once you have this abstracted and automated, it will keep running deterministically over time. So this is running on our Linux-based DevOps platform. It's using Make and CMake to build ISO glib, and then it uses the automated Parasoft wrapper that goes around the CMake interface, and that wrapper then performs the checks that we've just been talking about for AUTOSAR, as well as doing a full build of the application. So here we are, the CPP test CLI. That's the part of Parasoft that is invoked to do that reporting and that configuration. As I say, any new engineer could come along and use this platform and have the same rules, we check it to the same standard, and it's very easy to scale and to add new users to the system. So the Docker container automates the analysis. We have 187 rules enabled here, and as the pipeline goes there, we will also then go on to look at the architectural side of the analysis. So just a couple of points about Lattix as I'm waiting for the pipeline to finish. We have on our website a dedicated partners page for Parasoft to show off the use cases that we've developed. So if you go to technology partners here, you should be able to see some of these use cases in action that we've just been talking about. Here's our CI pipeline. The Parasoft part fits into both the static analysis and the testing phase. That then passes the data, as you've seen, to create the DSM using the new Parasoft module in Lattix. That's what I showed you, to load the data into Lattix DSM. And then we will put the data into heat maps and produce the documentation report automatically. The heat map, which I'll show you shortly, show you this picture, also imports data from Parasoft, so that for the first time, we believe this is the first time anyone can do this, you can visualize your AUTOSAR, your cert violations, your MISRA violations, your code coverage through the prism of the software architecture. And so you can see exactly where your architecture needs attention with respect to coverage, AUTOSAR, MISRA, and metrics that are used by functional safety standards such as stability, cohesion, connectedness metrics. So that's available on our website. Change-based testing is now enabled because the pipeline has that impact report that we showed you. And because of the impact report, we now know which test cases we tell Parasoft needs to be rerun in the context of the pipeline. And so the re-verification of the software is now blazingly fast because we are only changing what's changed and what's impacted by those changes. You'll see that this table that Andre was talking about earlier mentions control flow and data flow analysis. Within these clauses and within the AUTOSAR standard itself, the concept of coupling is discussed. It's elucidated here as part of the AUTOSAR guidelines and then reiterated in the tables. We have a unique solution now for data coupling between the two tools. So inside the architecture, what you can do is you can filter dependencies. And in data coupling and control coupling, we're interested in the problem of data being used by one module in another module across a module boundary that could affect the data or the control flow in another module. So this is particularly a concern in avionics. What we can actually do is we can reduce the dependencies to just looking at where data is written and read. And that will give us a reduced view of the architecture. We can see now all of these places where global data is spread and written and read between the different modules. We then run a report on that control coupling and data coupling, and we pass it to C++ tests for the dynamic verification using the desktop version of C++ test. So basically, we create an integration test that exercises those modules containing the data coupling and control coupling, and then verify the read and writes of those data and control flow segments. So that's a very useful way of covering that requirement. The new autonomous driving vehicle standard also requires data coupling, control coupling analysis now. So they've taken that in from DO178C. So we see that is a requirement for more and more functional safety standards now. If I undo that, you can see all relationships again. Okay, let's go back to our pipeline and see how we're getting on. In the merge request, there we go. Yeah, here we go. Here's the updated DSM. This is the full DSM, so you can see my new relationship from util funcs to part 10, the task controller, clients. You see that a little bit more easily if I showed you the delta though. So let me show you the delta DSM here. that shows you just what's new in this branch. So now, imagine I'm thinking about merging this code in. I want to check the architecture here. I've got a few new bad dependencies because of this relationship, which introduces this relationship. And also I've got my updated heat map also stored into the merge request. And that shows me that my quality for util funcs has degraded. And the impact analysis is also stored. So we have the full impact of changing to this branch. And here we see as well, our code quality has degraded. So this is pulling data now from Parasoft and Lattix together to show all of the AUTOSAR and MISRA violations. So here's an example. Here we have our AUTOSAR violation, 3 levels of pointer indirection. Here we have our dependency issue that was just been created, this bad dependency which is coming from Lattix. So in a matter of clicks, I can click from the merge request directly into the line of code that's caused the problem. And now I would say that this is not ready for merging, too many quality problems. I'd write to Frank and say, cannot merge, too many quality problems. And it will go back to the developer to fix some or all, ideally all of these issues. If you fix all of them, what you're doing is making sure your technical debt, there's no technical debt coming in from your branch. And that is utopia for those people who are merging in code all the time, but they have no idea how much technical debt they're bringing in. And it's only at the end of the merge that they find out that there's a whole load of code that's not been correctly tested. You can see also in this particular merge request, those test cases which passed on master are now failing because of my breaking changes. So I have the exact view of how much technical debt I'm bringing with this code if I merged it. Much better, prevention is better than cure. It's much better to fix these things in the branch before merging than to merge to master and then fix them afterwards. There's a huge difference in time and effort to fix things after the merge. And then finally, the exposed artifact. This is where you get the full compliance report. And this is the exact mapping of all those clauses for this branch, for the control flow, the data flow analysis, the MISRA, the AUTOSAR checks. Everything now is automatically generated, showing compliance to those clauses. And this file can be adapted for your own use, but this was actually developed in collaboration with the TÜV Süd in Germany. And you can see the Parasoft rule violations have also been picked up along with the DSM and the heat map and the coverage reports and the control and data flow checks and the results of that all into one report, which we can now circulate. So with that, I'll pause it and pass it back to Andre, I think, who will take us through to the end of the slides. Thank you, Andre.
All right. Thank you, Neil. It was awesome. Thank you for great demo. Let me, oops, I think I'm trying to make myself a presenter. All right, I'm a presenter now. Neil, do you see my screen? Everything good? Like the slides and everything?
Let me just go. Yes, I can. Mm-hmm.
All right, perfect. Yeah, just checking. All right, so as a wrap up, we have a couple of minutes left. We will be allowing questions, but as a wrap up, basically what Neil showed is a live demo of how you can take a source code and then build it with Lattix, with the source code. You can build an architectural representation in DSM and how we can analyze, set some rules there. With Parasoft, you can run a static analysis, create unit tests, and collect code coverage, show all of that in the execute all of that in the context of GitLab pipeline, and then produce the report. So I think it's just pretty awesome demonstration of how the two technologies can work in concert with each other to give you compliance documentation on every single build. All right, so we have that phrase compliance on autopilot. Once you're at the end of the project, it's a little bit too late to think about what you want to do for compliance. So it's easier if you just set up certain things there with tools and methodologies and rules in play, and then making sure that those are checked on every single build.